Alrighty, we're moving on today talking about dilations. This is the last type of transformation that we're going to talk about. We're going to finish up today. Many of you may have heard the word dilation before, or dilate, or something along that lines. A dilation is when an image or a point or a shape or a line, whatever, can either get bigger or get smaller. So if you think about if you're holding your phone, zooming in on something, that is a dilation where you are making the image bigger. If you zoom out on something, you're making it smaller. Okay, so the two words we use for dilation are the words reduce and enlarge. To reduce means to make smaller, enlarge means to make bigger. So when we perform a dilation, we are either making something bigger or smaller. Okay, we're either reducing or enlarging something. So I've got this rectangle here, HIJK, okay, and I'm going to have you copy this down. So point H is at 1, 3. Point I is at 2, 3. J is at 2, -1. And K is at 1, -1. Okay, so when we're looking at dilations or talking about them, we are also going to be using the term scale factor, which you guys have learned or heard about or whatever. Scale factor is the number by how much something is getting bigger or getting smaller. So when we use scale factor, we actually multiply it by the original value. So if you think back, you probably talked about scale factor when looking at like a blueprint. Like if you created a blueprint for a house or a building or something, obviously you cannot draw a house to scale. Your paper is not big enough to draw a house to scale. So you have to use a scale factor to make it fit on the paper, but make it comparable to the actual house, right? So scale factor we're going to use here for dilations. So for something to get bigger or enlarge, our scale factor has to be greater than 1. So if we multiply it by anything greater than 1, you're going to see your pre-image get larger, okay? For a reduction, your scale factor is going to be, greater than 0, but less than 1. Should put some spaces here. Meaning you can have fractions as scale factors, okay? So if your scale factor is a fraction, that means you're going to be reducing. However, you can't have a negative scale factor. We don't have negative sizes of things, so we don't have a negative scale factor. That's why when I say greater than 0, I'm just clarifying it can't be negative. So for it to be a reduction, it's going to be a fraction. So I'm actually just going to write fraction beneath that. Okay. So we call scale factor K, all right? So when I am performing a dilation, I'm going to multiply each X and Y value by the scale factor. Okay. All right, and we'll talk about what that rule looks like next week, but that's what you need to know. Okay. So let's take a look at this. If point H is at 1, 3, and let's say I want to, let's call my scale factor 2. Let's say our scale factor is 2. That means I'm going to multiply each X and each Y in an ordered pair by 2. So at 1, 3, if I multiply both of those by 2, I get 2, 6. So that is my point for H prime. 2, 6. Okay. Point I is at 2, 3. So if I multiply both of those by 2, I get 4, 6. Point J is at 2, negative 1. So if I multiply both of those by 2, I get 4, negative 2. And for K, it's at 1, negative 1. So both of those multiplied by 2 will get me 2, negative 2. All right, so here's my new rectangle, H prime, I prime, J prime, K prime. All right, I can also double check that my scale factor is 2 because I can, or by counting the length of each side. So this original or this pre-image, side HI is 1 unit, side H prime I prime is 2 units. So that got bigger by a value of 2. I to J is 1, 2, 3, 4 units. I prime to J prime is 1, 2, 3, 4, 5, 6, 7, 8 units. So it goes from 4 to 8, which means that multiplied by 2. So you can also look at the length of each side, and that will be affected by your scale factor as well. So lastly, we're going to ask ourselves, is this the same shape? Yes, they're both rectangles, and their side lengths are equivalent, we could say. But they are not the same size. And so we can't call these congruent because they're not the same size. So the word that we use for same shape but not the same size, but they've got equivalents to them, is similar. So this will result in similar figures.